So this session is about the proof by mathematical induction, and we have some sequences and we have to prove them true for the given conditions. Okay, so it says in this A part, if un is this, where u1 is this, show that un is more than 2 for all n is greater than or equal to 1. Okay, so we have to show that this is what we have to prove, that un is more than 2 for all n is greater than or equal to 1. Okay, now this is the given information to us, that we have been given that un plus 1 is 5un minus 2 over un plus 2. And then we are also given that this u1 is equal to 5. Okay, so let's start proving this. Now, first of all, the first step is that we have to prove this for n equal to 1. And we have to prove that this u1 is more than 2. So we are already given that this u1 is equal to 5, which is going to be more than 2. So this means this is proof that this un is more than 2. Next, we have to assume that we would say let it is true for this n equal to k. So we'd say k, okay, we would say okay, this uk is more than 2. Okay, and we can also put that k into this. This would become, this is not a proof, we're just substituting n with the k. This is uk plus 1, that is 5 uk minus 2 over this uk plus 2. Okay, so we have to prove that this uk, sorry, we have assumed that this is true for n equal to k. Next, we have to prove this, prove it to be true for, uh, we have to prove it true for n equal to k plus 1. So basically we have to prove that this uk plus 1 is more than 2. We have to prove this thing, okay? So this is where you have to show how smart you are mathematically, okay? You have to show your algebraic skills, in fact, here. So I'll be picking this thing from here. I'll start from this. I would say, okay, look, I have this. By the way, this working is going from here and then resuming to this. This uk plus 1, we have that is equal to 5 uk minus 2 over this uk plus 2. Now the scheme is, my plan is that I'll be writing here uk plus 1 minus 2, and I'll do that minus 2 to the other side as well. Let me tell you people why I am going to do this. Okay, I have brought this minus 2 over here. Now all I have to do is I would try to prove that all of this is a positive value. If I prove that this is positive, this is more than 0, I'll change this equality sign with more than, and then I'll put 0 here, and this 2 would go over there and this thing will be proved. Okay, that is my plan. So I'll be doing all that algebraic manipulation here to show that all of this is going to be more than, like this is going to be a positive value over here. Okay, guys, let's start doing that. So we have to prove that all of this right hand side is positive. Yes, beta. Yeah.
Can you please use other color other than red?
Yeah, I have changed the color, beta. I have taken the yellow color now. Okay, guys, now let's do
Okay,
some
teacher.
algebraic manipulation here. I'll first of all be taking LCM here. Okay, now this is, there are many ways of doing it, by the way. Each single person can do it different from any other person. So this is minus 2uk and minus 4. Okay, so we have 3uk minus 6 over this uk plus 2. Then I have this 3 into uk minus 2 over this uk plus 2. Okay, now I already have here that this uk is more than 2. We have assumed that this uk is more than 2. So if uk is more than 2, let me cover this area here so that I have some space to prove this thing here. Okay. Okay. So I'll be using this area now. Now, from this over here, that we know that this uk is more than 2. Okay. Then if I write it as uk minus 2 and this is 2 minus 2, so that means uk minus 2 is a positive value. That is the first relation. That is about the numerator of this. The numerator of this fraction over here is positive. The secondly, for this denominator, again uk is more than 2. And if I write plus 2 here, and I write here plus 2 here, so this uk plus 2 is already more than 4. And we can also say, okay, look, this uk plus 2 is also positive. So if the numerator is positive, if the denominator is positive, from this 1 and 2, you can let me say that this 3 into uk minus 2 over uk plus 2 is positive. That is positive. है ना? क्यों बच्चों? Hello?
Yes, sir.
Yes? Okay. So now I'm going to cover this area because I have to write the conclusion now. Um, so we can say that, okay, we can say from here, like, um, we should have space over here to write under this. So I'll be writing, like after having been proved all of this, I'll be writing this as that this uk plus 1 minus 2 is going to be positive, and then this uk plus 1 is more than 2. So we have proved that this is true for n equal to k plus 1 as well. So um, we are going to say that, okay, as it is true for n equal to 1, and if true for n equal to k, and then n equal to k plus 1. So it is true for all n greater than or equal to 1. So that is how we prove this. Okay. Now, do you want to see how? Let's see how this book has shown this. Okay. So they have gone up to here when, like, they were using this, they introduced that minus 2 on the both the sides, and they took the LCM, and then they have divided the numerator with the denominator, and they got this. And then they have a plea here that, look, uk was more than 2, so 12 over this is going to be less than 4. So sorry, less than 3. So 3 minus less than 3 is going to give you a positive value. Okay. So that is how, they have proved it. Okay. So let's try proving the second second problem here. You give it a try first, and then I'll do that in the next segment.